Welcome to episode 8 of ChessWhiz Arcade. Today is July 2nd, the same as episode 149 of ChessWhiz TV. We took a week off of our programming last week to recover from an illness, and now we're feeling much better, feeling healthy and ready to go. But we're a little bit not quite caught up on programming. We haven't opened up this project in 2 weeks, so a little bit behind. I haven't been cheating and programming behind your guys' back, but that means we're a little bit behind. So let's get familiar with this. Let's actually just go open up the project and see what we've got. Desktop view, start Visual Studio, ChessWhiz.solution. I named my solution after myself. Can you blame me? I'm just that awesome. Goodbye counter. Let's close my website. Let's go to localhost, but not until we start the project. I always hate it when I open up the project and see that there are things to be checked in. There's not. That's good. So let's start the project. So we've got some server-client communication going on with SignalR. That's good. The problem now is cheaters can cheat, and that's the point of this episode, is to stop them from cheating. When you send in a move, Iceberg, that's correct. When you send in a move to the server, you just say, make this move, and the server makes the move. The problem is, on the client side, you can't move 2 moves instantly. Is this started yet? Let's see if it's starting. You have to have a short delay between moves. I think it's started. Let's browse there. Is this website running? Starting. This item does not support previewing. That's okay. There we are. Okay, we're on localhost and we're gone. So here's the game. It's called Uprising. You move your knight around the board to capture pawns and other enemy things. And you can see if you want to move twice in a row, bam, bam, there's a short, you can't move 2 moves instantly. There's a short delay. And that's the number of moves you can make per second. I'm not sure what it is, but it's a constant in the code. The problem is cheaters can, whoa, catch that queen. Cheaters can cheat, and they can send a whole lot of moves in a row really fast. They can programmatically say, I'm going to move my knight. I'm starting down here, wherever I'm starting right here, and I'm going to go bam, 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 super fast all at once. And the server is so clueless. It just applies those moves. That's not fair for the real guys using the real client software that doesn't allow instant moves. So we need to make sure that moves don't come in too quickly. We need to space them out. Also, moves could come in out of order. It could be that move 6 arrives at the server, and then finally move 5 arrives. So the server needs to be able to handle that. And that's also the objective of today's episode. In order to prevent cheating, we have to keep track of what order the moves are coming in. Because otherwise, the cheater could say, well, I'm moving here, and then here, and then here, and then I'm moving here. And the code will say, oh, well, I see you've made this move, and oh, you already made these, and it will just teleport the guy up to here instantly. So that kind of teleportation is not really allowed. If it were, then you could just send in moves for every move everywhere, and then just, you know, it's like pre-moves in chess, except it's multiple pre-moves being executed instantly with no opponent's turn in. It's just cheating. It's cheating. So let's see what we can do about that. So I've got a lot of code open here. Let's just close it all because I don't know what I'm doing. And let's take a look at the hub where the move comes in. So when a move player comes in, this is the call. The server is receiving a call that says, oh, the knight is making a move. First it says, is that move legal? No, it's not. Fail. And it opens up a database context and it gets the game. It says, there's no game here. I failed again. Okay, so we got the game. Now we get the player. This is all reasonable. Don't allow moving off the board. Illegal move if you moved off the board. Very good. Now make the move. Now this make the move, that needs to be changed because you can't just apply the move. You have to make sure it's not occurring too quickly after the last move. You have to make sure that it's it's not out of order and all that stuff. So I think there's a move number in here. Yeah, there is. Okay. So there's a call here to actually apply the move, right? No, this is it. This is it. So here's what make the move does. It makes a new move object in the database. It says I'm moving in this direction, and then it updates the player's position. We can't do that because it may not be legal. And then we say you're making another move. So we're going to go into the player logic pop thing, and right now it's all static. And it's going to, oh look, we already have something called resolve move. Oh look, it already does this stuff. Does a move have a millisecond number? Yeah, it does. Save. store. We're going to call this store the move because you are allowed to say I'm moving in this direction and this is my move number. The move number needs to come from the client though. So we can't just say that the move number is the player's next move number. It comes from the client. Oh, there. And the milliseconds is not a pending move, and is pending. It's going to be false by default, so I don't need to set that. And there's the player. So let's go to the client and make sure we're sending the move number. Here's the world. By the way, if you have any questions about this, feel free to post in the chat or in the YouTube comments below the video if you're watching on YouTube. And by the way, I recommend if you're watching on YouTube that you speed up the playback. There's a little gear in the corner down there, and you can make the playback a little bit faster. And then just slow it down when it gets interesting, because programming is not always the most amazing thing to watch. So here's the move, the call that makes the move. And it does send the move number already. So it's sending that right there, and that's arriving right here, move number. So we're going to save the move number, dun, 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 and this is applying the move. So I think we want to move that over here. Result apply. We'll call it apply move. We are applying the move, and that means to move the player in that direction and increment their move number by 1. That's always safe because you always apply moves in order. What else does applying the move do? It finds a captured enemy. And let's steal this code as well. So I don't have access to the database. So I'm actually going to pass in the database context because I'm a cheater. So that is called ChessWhiz context. There. You pass in a context. And I'll save changes later. I might not need that. Let's see. Uprising enemies.remove. So doesn't the game have enemies? Why doesn't the game itself have a list of enemies? It does. It's called enemies. I think that's just as reasonable. Maybe I don't need this after all, because I'm passing in objects that are already inside that context. So I don't know if this is making sense, probably already going over your head, but the context is a way to access the database. I don't think I need to pass that into this function, because I have a few objects here, the game itself, which is all of the information about the game, and the player that's making the move and the move itself. Oh, this is what I don't have. Let's have this return an enemy. A list of, what does spawn return? Enemies. This is going to return a list of enemies that are spawned. You apply a move, and it returns a list of enemies to be spawned. Does it need to do anything else? Yeah, it does, because it's like going to push score updates and stuff. This is a problem. This needs to do a lot more. And this is why this can't go over here in this static class, isn't it? I should have thought about this. Okay. Where's the FF on Twitch? I don't know what FF means. Firefox? Where's the Firefox on Twitch? Doesn't make any sense. This is a signal R call to tell all of the browsers that we're spawning a new enemy. But I can't do that. Uprising player moves.add. So this is going to be player.moves.add. That's much more reasonable. Instead of starting from the context, it starts from the player, which works just as well. The problem is notifying. I guess this could return a list of functions. And their parameters to be sent back. Right? Like, it'd be like, okay, I'm returning a list of 1, and the element is spawn. Where's the fast forward on Twitch? Yeah, great question. I wish I could just fast forward my life right now, because I'm sweating. So I know what to do. I can't access clients, so I'll pass that in. How bad could it be? What is the data type of this thing? It is a, oh. It is a I-hub caller connection context of dynamic. That might not work. Let's try it. Need to include something signal R. Could work, could work. We'll find out. What's wrong with db.save changes? Oh, it's fixed now. Yeah, let's build. So the same code is being run, except some of this logic is moved into apply move. Player logic.apply move. And we're going to pass clients. We're going to pass the game. We're going to pass the player. We're going to pass the move. Let's see if this works. So if this works, we will see moves in LinkPad as we play. Here's my database. Here's my player moves. I select the 100 of them. Order by move number. Order by descending. I think it's desk. Oh, it's not. It's descending. There we are. So there's no, don't order by move number. Order by ID. So the newest ones are on top. Let's play again. Ready? 3, 2, 1. Pin that over there. Go. And there's a move. So did it put that in there? Yes. Now there's another move. 2 more moves. Put those in there? Yes. And put those moves in there? Yes. So it is putting those moves. And look at that. The game is working. The game is working. So that means that passing clients in that way works fine. Okay. So now that apply move is its own function, we don't have to call apply move right now, although we can. Let's think about cheating. So cheaters send in messages that have that are out of order. If the current player's next move is not the move number, then the move is pending. Otherwise, we'll run the player logic. Right? So if you send a move 5, but 5 is not your next move, and will be pending. I'm interested to try it to see if it still works, because it could be my move numbers are off by 1. There's an old error in computer science called off by 1, and I get that happen to me a lot, so now I'm a little better at that. Why isn't there a knight here? Okay, here we go. Ready? There's my first move. A couple moves there. 0, 1, 2. And his pending is still false, so it is applying the moves and it is working. Great. Great. So that's going to catch. It's not going to apply moves that are pending. Now we need to make sure that the moves are not coming in quicker than they're permitted. So let's go find out just how fast moves are allowed to be made. How fast can you move? Piece speed is 12. What does that tell us? Let's search the whole solution for piece speed. We're finding out, whoa! Let's just search for piece speed. We're finding out how fast your piece can move. Square size divided by piece speed. This is a bad way to do it. It's dependent on the square size, which is the how many pixels the square is. So let's see where else we're using piece speed. Are we really not using it anywhere else? Setting it to 12. And then we're moving by that many pixels. So instead of this way, I'd like to take the square size out and just say how many moving frames you're allowed. And so we'll call this, instead of p speed, we'll call it frames per move. Actually, it's going to be milliseconds per move. And it was 12. The other math was square size divided by p speed. So square size, I believe, is 128. There it is. And p speed is 12. So if we bring up the calculator, we will see that it was doing 10.6 frames. That means 10.6 repeating frames per move. No. 10.6 repeating frames, yeah, per until you can get to the next square. So if your knight is trying to move from here to here, it's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.6, and then it arrives. So that's like the speed that it's moving. So the new rule is going to be 10. That's a little quicker, and quicker means, oh yeah, there it is. 10. I mean, quicker means more skill, right? The knight will move a little bit faster. Cool. Okay, so we're going to say that it is 10 frames per move. But there's a catch. Frames are not milliseconds, and the server is doing everything in milliseconds. It's the only way to be fair, because things could get a little bit out of sync. You have to keep track of the milliseconds. So let's go to the clock manager and just see how many milliseconds per frame there are. Oh no, 16.67 repeating. Or 6 repeating, clearly. 6, 7 repeating, that would be stupid. So we should actually have 166 milliseconds per move. Right? Should be 6 repeating, but we're going to use whole milliseconds here. So that's the rule. The rule of this game is you are permitted to move one move every 166 milliseconds, which comes out to about the same as it was. And we're going to apply that rule here. See if this worked to switch back to full screen. Yeah, okay. We're going to apply that rule. Milliseconds per 166. So now let's go find where this old variable was used. It's no longer here. Moves remaining equals milliseconds per move, which is 166, divided by milliseconds per frame, which is in here. Clock manager. Which is 16.666. So this is not going to be a whole number, but I don't care. I think I don't care. So let's pull out the calculator and say 166 divided by 16.6 equals almost 10. See how it's not quite 10? That's because it should be actually 166. No, it should be 166.66 divided by 16.6, and now it's 10. Okay, so that's coming out right, 10 frames per move, but I don't like how it's not a whole number, because clearly it should be a whole number of frames. But I think we're going to have to live with it. Maybe we should do less. 150. 150 milliseconds per move. That's going to be a little bit faster. So now this code works. Milliseconds per move, 150 divided by milliseconds per frame. That's going to be some number that's a little bit more than a whole number, or a little bit less than a whole number, depending on your perspective. Let's go see where else it's used. The knight was being moved over by p speed pixels. Now it needs to be moved over by ms per frame divided by clock manager dot. I think that's what I need to do. I need to move over by this much, or maybe divide the other direction. We'll find out when I do it wrong, and then we're like, wow, that doesn't work. So this is 16. This is 150, and this is 16. So that's backwards. Oh, that might be right. This is so difficult. So let's say span x is 1. That means we're moving 1 square over. Okay, don't need that line. Blank line. We're moving 1 square over, and then we're going to multiply that by this. I don't think that's right. 166 over 16 is like, I think it's right. I think it's right. Let's try it. So piece speed should be gone now. If we search for, and that's the other spot. So if we search for piece speed, should not be in the solution. Good. And if we search for, the other thing is that we've changed now. What did we just change over here? We're setting moving frames remaining, so let's search for that and just make sure that it's okay that that's not a whole number. We set it to 0. We say if it's more than 0. We set it to an irrational number, or yeah, it's irrational. Or maybe it's unending anyway. We check if it's more than 0, we decrement it by 1, and we check if it's equal to 0. So this should be if it's less than or equal to 0, because it could go below 0, from above 0 to below 0, because it's not a whole number. Okay, let's try it. I think the knight won't move properly, but we'll find out. Hey! It kind of jumps. How is it? What is happening here? It's moving a few pixels, a few squares slowly, and then it jumps. So it's moving too slowly. It jumps because it's arrived at the destination. So what if we take this out? We just multiply by that. This is called trial and error programming, because I don't know what works. So let's see how, if it moves super fast here. Yes, it does. Really fast. So that's not right either. 1 times, this is where we think. Okay, 1 times, I've got a number that's 166, and I've got a number that's, oh, I know what needs to be part of this equation. The square size, which is 128. It needs to be milliseconds per move divided by square size, right? No, square size divided by milliseconds per move. Milliseconds per frame. Do I need all 3 parameters or just 2? I really have to figure this out in my head before I just put it on the page like this. 1 times the square size times, and then a number that equals to a number that's less than 1. Milliseconds per move is 166. So I actually think this will work. Okay. So every time you move, it's going to move over by 1, and it's going to move over by the entire square of pixels. And then it's going to, no, not the entire square. It's going to scale that down by this division, which is less than 1. I think it's going to work. I don't have to explain it. I just have to run it and say, look, it works. So there. And is that true? Yes, I fixed it. Okay, it totally works. Square size was the missing ingredient, and I mixed all the ingredients together in the proper order, and now the knight moves properly. The difference now, what did I accomplish with all that, is that we know that you're allowed to move 1 move every 150 milliseconds. That's the rule, because that's the rule over here. Milliseconds per move, 150. So because we know that's the rule, we can also apply that rule to the server side. So here's the server that's actually enforcing the rules, and it says milliseconds per move equals 150. I'm just throwing that in the globals, now you know. So now we're going to apply the rule in the help. So I used to say, if you make a move, it comes in, I'm going to say, whenever I got that message, that's when the move was made. Now I'm going to say, whenever I got that message, that's when the move was made, except if it was less than 150 milliseconds since the last move, then you're cheating. So I'm going to move that out to a full 100 milliseconds, 150. So math.max, that means the bigger of the two between, this is the first one, and the second one is dot max x dot how come I don't have any lambda? Oh. Select dot I want to say the move that's most latest. That's most recent. There is something called max. The maximum of the milliseconds plus ms per move globals. That's the correct code. Why didn't I get any IntelliSense? I have no idea. It's unintellisense right now. So this code says the time that this move came in was actually, instead of just saying whatever time it arrived, it says, well, whichever is more, whatever time it arrived, or the latest move that you've made plus 150. So if that's more, then it's going to use that. Which means if you're cheating and moved yesterday, well, I'm going to say that it's more to say you just moved, and so I'm adding 150. That's going to help a lot. And I think that we're not going to see any difference here when I run it and look at the database. But we'll still try it out. I'm trying to move as fast as I can to just test it out. You know, wow, I'm pretty fast, right? It says wait over there. I think something crashed. Let's see what happened. Did I just do all these moves? I don't even know. Let's refresh the page. Get ready. First, I'll make one move. Okay, let's see if that shows up. It does not. It crashes. The code crashes. So let's run it in debug mode and see what's crashing. That's a breakpoint right there. That breakpoint will be hit when we make our first move, which is now. DV Razor says 7 squares per second. No, it's not 7 squares per second. It is 1 square or 1 move every 150 milliseconds. You got a problem? Oh, I knew this would happen. Why didn't I think of it? Sequence contains no elements right here. That tells me that there's a list, that I'm trying to get the biggest element of the list, and it has nothing in it. Now, obviously, that should return 0. The move with the most, right? But I can't do that. I should probably pull it out like this. So I don't have all this complexity right here. There, moving some complexity out. Now, and now milliseconds, and the last move milliseconds. So now I can say the millisecond that you're moving at, soonest possible move. So I'm going to say whichever one is bigger, that's the one I'll use. So I don't know. MS is a weird suffix on that variable name. So the cheat here is player.moves might be empty, so I'll use a ternary operator. Player.moves.any. If it has some, then evaluate it to that. Otherwise, 0, which is fine. Yeah, if there's any moves, then it's going to say, okay, the last move plus 150 milliseconds. If there aren't any moves, then the next possible move is at millisecond 0. I'll run that in debug mode to see what happens. It should work. So the very first move won't crash now, because it's not going to try to get a list of moves, and there's 0 of them, and try to get the biggest number from a list of 0 and say, I can't do that. Annoying. Why doesn't it just say, well, there aren't any here, so your answer is 0? That would have saved me a lot of trouble in the past. Okay, it worked. Here's my move at millisecond 4424. So now we're going to go fast. Illegal move. Nice. The moves came in out of order, guys. Exactly perfectly. I threw an exception that said that was an illegal move, and that's because the knight Wasn't there, and now we found a bug in the code because the knight isn't where it thinks it is, right? So here's the move, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then number 13 and 14 came in out of order. Number 14 came in next, and it said, how you can't move from there to there. Why did it say it was an illegal move, though? Oh, it said it was off the board. Let me think about this. Let's think about this. It's not today's move. It's tomorrow's move that just came in. Move 14 came in, and 13 hasn't arrived yet. So we shouldn't be checking if it's illegal or not. What else should we not check? We should always check if it's a legal knight move, just the direction. So we'll leave that there. We should check if the game's not found. So we need to not prevent moving off the board. Should we just not prevent moving off the board? No, I think we should prevent moving off the board when we're applying the move, as opposed to later on. So this is when we're making the move. Right here, we're going to say illegal move. And that's the new rule. We don't see if you're moving off the board till we're actually moving you, because you might not be where you are at the end. Okay. We're going to try that again now. We're going to try to make a move that's out of order by moving super fast. It's going to be fun. 7 squares per second. 1 square per 150 ms. Interesting concept. 6 point per second. That's the new speed limit. Running, looking at link pad. I hope that I'm not. No, I'm sorry, guys. I'm sorry. You're looking at me instead of the computer. I'm so sorry. We're back now. So what I did there when you couldn't see was I moved. Wow, you really couldn't see any of that, could you? So it hit this exception in the hub. It was checking if the move was legal or not. I'm so sorry. That was terrible. In the hub, and that was applying the test too soon. It was applying it instead of when you're making the move, it's applying it when you receive the move, which since it was out of order, it broke. So I've just said everything again, but now you can actually see where I moved the code. I moved this code to apply move, the is move off board code. That's what I did. Sorry you were just staring at my bad haircut that whole time. Okay, we're playing. Go, 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 capture that. Got it. Move number 0 is, I think it's crashing. Still says 0. Let's try that again. There's 2 moves, 0 and 1. Okay. 1 through high 6 7. Okay, looks good. Let's go capture that. Somehow it crashed before. Don't know how. Okay, now let's. Oh yeah. Made my illegal move there. How did it get in and make an illegal move? It shouldn't be able to. So it should say, it should mark it as pending instead. Did we get any moves that were pending? No. Pending means it's not applying the move yet. I got 2 in a row. In the same direction here. Let's try it again. This is interesting. Catching the cheaters right now. Up, back. We're going to try it up here. Let's look here. Do they alternate? 1 minus 1 minus 1 minus 1, 2. That's too confusing. Let's try this direction. Game over. Ah, I lost. Is it still? Still. That's dumb. We'll try it this direction. Here's the illegal move. So let's take a look at the code. Let's take a look at the data. See right there? Moves 15 and 16 came in out of order, and the knight's position got wrong because it moved the same way twice, and then it tried to do it again and failed. So the knight got out of sync. The question is, how did it actually end up evaluating? Because I think that over here it should say that the move number shouldn't match up. This really makes it look like move number 15 was direction x, 1, and move number 16 was also direction x, 1, which maybe it was. Let's try it one more time, and I'm not going to move out of the corner, so it's going to be really simple. I'm going to stay right here. So if I move out of the corner, you're going to see, bam, there's my exception. So now let's take a look at the database. What happened? 1, 2, 3, 4, 5, 7, 8, 9, 10, 11. 2, 1, 1. It never. So what's move number? What's the move I'm trying to make right now? It is move 12. And that has not yet been saved in the database. And it is what direction? Direction -2 and +1. So it's trying to make the same move as move 11. So, hello Klein Welt. I am programming now, not playing chess. How is it that the client is actually sending that? It's like a bug in the client saying 2 moves in a row are in the same direction. Because clearly I'm not meaning to move in the same direction. Well, let's try this as a debug thing. As a debugging attempt, we will disable talking to the server. The server never knows when we move. But now we're going to log x. This. And this. We'll put that in the console. Oops, refresh the wrong page. Lost all the chat history. Start that up. So instead of telling the server where we're moving, we're just going to output it to the console, which should show up right here. And we'll see if the client actually does send bad information. Hey, let's have the knight. Cannot read property piece if undefined. What's it doing? Looks like that's where it's going wrong. It's sending the same thing multiple times. It sent that 4 times. Yeah, look at that. 5? Doesn't that mean it outputted that 5 times? So that's the problem. It's sending 5 moves. It has to do with the pre-move module. But it also is trying to read piece of undefined on line 41. So let's take a look at that exception. Separate issue. Direction equals player.piece.getDirection. How could piece be undefined on this.players? Does that occur over and over or just once? 23 times. Oh, it's when I try to move before the knight's loaded, I think. Oh, we're not going to see that exception now. Yeah, that's not a big deal. So it has to do with the pre-moves. When I get cranking and you see pre-moves here, then you see a lot of moves. So that is the problem. This dot move direction, 0 in direction. So it's a problem in the client. The client actually sends multiple of a move. It says, I'm going to move there many times. And of course, before we hooked up the server, it worked fine because it ignored the illegal moves. But now the server is saying, hey, those are illegal. So the fix, of course, is to tell the client to stop sending all that. We really shouldn't be delivering such a message. Okay, so it's with a mouse move, and it is if you gets the destination, stop move 0 direction, player 0, take a peek in the piece move.move function. We're communicating the move at the wrong time. This is the line of code that tells the server when we're moving, and it tells it too soon. It needs to tell it way down here because done moving calls next move. So it needs to happen down here. That might fix everything, but I have a feeling it still won't. Let's try it. It has to do with pre-moves. The knight is on its way. Here's what it is. The knight is on its way to this square, but it's currently right here. It's not yet there. Meanwhile, my mouse has moved somewhere else. In this case, I've moved back to this square, but it could be any other square. So my mouse is moving around over here. Each time it makes a tiny move by 1 pixel, it fires that call that says a mouse move has been made. And then it says, okay, you're moving here. It says, well, you can't move there yet because you're still back here, but I'll remember that. And then when I do arrive here, then I'll move up. That's what this function, next moves. That's what this next moves array is storing the moves that will come next after the move is complete. So finally, that's able to happen and it makes the move up. The problem is when it's storing that is when it's telling the server, hey, I'm gonna move up there, and it tells it multiple times. So let's try it now. The same thing with the communication to the server at a different spot. And that means that the write to the console needs to have a different spot also, which is right here, right? The time that I'm telling the server is also the time that I'm logging it. Go. Oh, it's totally crashed. Piece line 64. Oh, I can't communicate this. Good thing I can access the world super easily with my hacky global. Okay, go, 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 knight, go, 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 pre-moves and all. Hey, it did send 2 of the same thing, but that's because it moved twice in one direction, so that's okay. Go, 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 pre-moves, faster, faster, go take that and play some more. Go, go. Nothing appeared because it's not telling the server. Wait, it is telling the server. I uncommented that part. Why didn't anything more appear, I wonder? Oh well, it seems to be working. There seems to be no illegalities now. So let's take a look at, I don't think it's telling the server anything. Let's take the log out. So what I'm interested in doing now is cheating on the client. Let's turn on cheat mode. Cheat mode is milliseconds per move 15 instead of 150, okay? Let's run this in debug mode so we can hit any exceptions and that sort of thing. So this, I have modified my client code. This is the cool part, guys. I've modified, where's myself? There I am. I've modified my client code so that it only takes 15 milliseconds to move instead of 150. So we're going to see the knight go pew, 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 super fast like a cheater. But the server is going to say, hey, now I'm not permitting that. I'm going to actually do the slower version. So let's see if the server correctly stores the legal moves in here. Now we find out. Ready? Set. There's one move. Look how fast that is. See, cheat mode is on. So now let's check those moves. There they are. Okay, now ready for super fast cheats? Go! Hiya! I can't even mouse that fast. No. So now we look at this list and we're going to see cheater moves, right? All these moves were super fast, but this is where we come down with the band hammer. They're actually 150 milliseconds apart. This is the millisecond of each move. You can see these are exactly 150 apart. So the server is saying, even though you're cheating, I'm not storing your cheat. I'm storing as if you were moving at the speed limit. So there's no speeding permitted. So that works. Awesome. So we thwarted the cheaters. So that's a good stopping point to check in the code. Let's make sure the code is what we like. So this is source control over here. And we can actually see what changes we made in the hub. Oh, we can't authorize access the source control. Let's go online. Oh, I like get a login prompt here. What do I click? Yeah, I know I'm not authorized. Can I please log in? What happened? Oh, you detected some pretty awesome files there. Why can't I access my own source control? That'd be nice if I could do that. Connect to team projects, this one. There we go, there's the prompt. Now I'm gonna go, so you can't see me typing in my password. I'm typing in my password. See if this works. Connecting. Configure your workspace mappings to get started developing. I am done typing my password, so let's see what we got. Source Control Explorer, not that. Pending changes. Great, there we go. I don't need Source Control Explorer. So now I can see the changes I've made. Here's the changes I've made to the hub. I have stored the move and moved all that code out. Here's the changes I've stored to change the globals file. I have added milliseconds per move 150. To the player logic, I've added resolve move. I've named it apply move. Then I changed the piece file by making the piece be the one that tells the server. I have changed piece speed to milliseconds per move. And I have changed slightly the handling of the frames remaining. So apply speed, server size, speed, limit to player. Done. Cool. Next, we handle moves that are out of order. Now, here's how we can simulate moves that are out of order. We can slow down the browser. Right now, the browser's super fast because it's running on my local machine and the database is on my local machine, the code, server, client, it's all on my machine, so it's really fast. But in the real world, it's not going to be fast. It's going to be out there in the real world. So let's try slowing it down. This log wait, and this could actually also go in player right here, because wait happens when you tell the server. So I'm actually going to say, I'm going to slow down communicating the server. So what this is going to do is say, instead of telling the server right now, I am going to tell the server in a random time in the future. This is a function that does something in the future, and it's going to tell the server, and it's going to do it 500 milliseconds from now times a random number between 0 and 1, which means 0 to 500. So it's going to randomly take 500 milliseconds longer than you would expect, up to 500 milliseconds longer. Let's try that out. Let's try it out with working. If you have any questions, feel free to ask. See what happens. See the wait up there right here? It says wait at the time that it sends to server. So I finished the move before wait, actually. In fact, it never says wait. Why doesn't it say wait anymore? Flickers wait. I thought it would be longer than that. Let's try again. Oh, I know why. Let's see if we have any pending moves in here. We don't. Let's go capture that quick. Oh, too slow, Joe. Weird. It says okay. Should we make it delay a lot instead of 500? Let's do 5,000. Let's make it 2 seconds. Let's make it 1 second, and let's not randomize it. Let's just say each move is always a second behind. See what that does to it. So now it's going to take a full second for the server to hear about the client's move. That's a long time. And I anticipate move number 1 should show up here. Is there a bug? Why doesn't move number 1 show up as the first thing right here? Set timeout, window.setTimeout doesn't exist or what? Let's put a breakpoint in there in piece right here. There it is. It's hitting it. Okay. So that should have written in this box, move number 1. Why didn't it do that? Try another move. Lost connection for a moment, so my internet connection went out, but it's back now. That's good. There's the knight. Move. Hit the breakpoint. World players O.key is equal to... It is making the call, but nothing goes in the database, and it should. So why not? Let's see if it's hitting a breakpoint on the server side. Does it hit this breakpoint right here? And I'm back. Twitch is having problems with their connection. Or I am. Somebody is. My internet looks fine, so I'm not sure why it keeps going up and down. But I am back. And I'm typing in the chat that I'm here. So I do hit that breakpoint. And is that going to save itself? Oh, I put... Oh, I see the problem. Move number... Why is move number 1? I think I know why. Move number got switched down to 1 from 0. Because it's the set timeout thing. Right, when does this go up? When does that get incremented? Right here. You know what? That should not be incremented there. It should not be incremented there because it might be a future move. So let's take it out and put it in the piece. At the time you're telling the server is also the time that it should be incremented, right after. But we found a separate problem, which is it's not saving to the database at the end. It applies the move. And see how it adds the move here? It needs to add the move way back here. There. There we go. That's more like it. It was only saving to the database if the move was not pending, because the save was inside of apply move. So we obviously need to add it afterward. Interesting. This is confusing. Fighting cheaters is confusing. Now let's go look in the database. Pending. They're all pending. Is that one pending? They're all pending. Let's see if I can get one that's not pending. Come on. And is that not pending? That's not pending. So it's working and it's setting the moves to pending. So the next thing I need to do clearly is say when a move is completed, if there are any pending moves that still need to be done, check for those if they should be done right now and apply them 150 milliseconds apart. But I don't feel like implementing that logic right now because I'm all worn out from losing my internet connection and other things. So I hope you guys enjoyed this and learned from it. I'm actually stopping the episode now, but we'll be back next week on Thursday at 7:30 p.m. GMT after the chess show. For more information or to play this game, visit ChessWhiz.tv and click Arcade in the corner or in the menu there. And you can play it now. The version I'm working on here is not on there. There's an older version that's client-side only, but we're working on integrating with servers. So once that's done and playable and kind of bug-free, then we'll publish out the website. But right now, it's being held back because it's still buggy. So that's what's going on there. So I hope you enjoyed the programming. Hope it wasn't too boring for you. Perhaps you learned a thing or two. It's kind of fun to be building this program in SignalR because it's my first serious game or even program using SignalR. But when it's done, it's going to be able to support multiplayer. That's the big idea, is the server is arbitrating the state of the game so that multiple clients can connect in and move their knights around at the same time. That's going to be a lot of fun. But I don't see it happening really soon because it's kind of slow going, but we're getting there. We're getting there. It's been fun. This has been ChessWhiz Arcade episode 8. Thanks for watching.